He'll let you do it.
I'll take them. We do like a
All right, here we go. Shh. We're doing the distributive property. We practiced with PEMDAS. We wrote down our standards and our objective. Okay. Here's a little bit of input. That's rude. Okay, here we go. Combining. Oops, I can spell. Like terms. Combining like terms. When you are combining like terms, first thing, you need to, hi Katie, you need to find the same or like terms. Thank you. Okay, so you need to find the same or like terms. So you need to find all the terms that are the same. If there's a bunch of x's, you can find all of the x's. If there's x's and y's, you need to find out which ones go with each other. So you find the like terms. Number 2, you're going to add or subtract the like terms. You're going to add or subtract the like terms. So like I said, if it's 3y plus 3y, they both have y in them, so you just add the term. 6, 5, 3 plus 3 is 6. 6y. So you'll add or subtract the like terms. And the last step is you will solve. So that's one part of our input, is combining like terms. When you have written that down, put your pencil up, please. That'll be one part of the lesson. The other part will be using the distributive property. Okay. The other part will be the distributive property. So there is one language of the discipline word that you need to know, and that you probably do know, and that is the word distribute. What does it mean to distribute? Know it too? Okay, distribute means to multiply the sum or difference, to multiply the sum or difference by the number on the outside of the parentheses. So distributing means to multiply the sum or difference of the number by the number on the outside of the parentheses. You distribute the number in. You have that written down, please put your pencil up. Everyone should be writing. See some tables with their pencil up, others not. Okay. Awesome. Calling models. Oh, come on.
Multiple models. Yeah, could there be multiple?
No, you just need one.
What do I? There's nothing.
Just go in a circle.
Walk in a circle.
Yeah. Ready? 1, 2, 3. Everyone says Natalie. Oh, there's model.
Walk around the classroom. Walk around the classroom.
Oh, we didn't even see your face.
I'm sorry. Hello.
There he is. All right. Thank you, Travis. That was a great job, I would have to say, sir. Okay, here we go. So I'm going to be modeling for you. I'm going to be modeling for you those two components. Okay? Oops. Here we go. Number one. You might get something like this. Y plus Y plus Y plus Y. Oh, nope, nope, not right now. I know, yeah, relax. Okay, so when there is a variable that doesn't have anything in front of it, there's actually a secret SPY number in front of the variable. That secret SPY is the number 1. Okay, so step 1, you're going to find the terms in front of the variable. It's good, there are no terms in front of the variable. Yes, it's the secret SPY number 1. So technically, you have this in front of you. So technically, secret SPY number 1 is in front of you. Okay. Is a secret SPY. Step 2, you're going to add or subtract the numbers. So secret SPY number 1 is in front of Y. It's homework. 2, right? Okay, so you're going to add or subtract the numbers. So we're basically adding 1 plus 1 plus 1 plus 1. 1 plus 1 plus 1 plus 1 is 4.
4Y. 4.
Oh, Miss Graham's talking. Think of it in your head. And then you put the variable at the end. So your answer is 4Y.
This is so nice.
Dude, I knew that one.
Good job. Shh, we're quiet. Nope, we're quiet until I'm ready. So your step 3 that you just did was put the answer in front of the variable. I'm writing, so you are too. So you just put the number in front of the variable. Travis is ready.
Yes.
Quick.
Hands, please. Okay. So using those same steps, we can solve problems like this. 10x minus 4x minus x. Oh, Miss Graham, it's crazy. Let's just identify, Zach, the number that's in front of the variable. We have 10. We have 4. And we have secret SPY number 1. So that ends up being 10 minus 4 minus 1. That makes sense? Here's 10. Oh, shh, quiet. We're looking for the number that's in front of the variable. The variable is x. The number in front of it is 10. Do we see that?
Yeah.
The number in front of this variable is 4. We see that?
Yeah.
The number in front of x is the secret SPY 1. You know, we see that? This is subtraction signs. So we keep the subtraction sign.
Yeah.
Does that make sense?
Also,
Yeah.
whenever it's by itself, it's always going to be a 1.
Yes, sir.
Okay.
So then you do 10 minus 4 minus 1. Well, 10 minus 4 is 6. So then we end up with 6 minus 1. And what's 6 minus 1?
5.
Yes, 5. Now step number 3 tells us that we need to put that number that we got, the answer, in front of the variable. So the answer, and what's the variable we used?
X.
5x.
X.
Very, very easy.
This is very easy today.
Keep it to yourself. Put your hands on your head if you understand. Okay, so that's what you're going to be dealing with, finding the like variables. Now, there might be times where there's an x and a y. You can't combine terms that are not the same. For example, what if you had 3x plus 2y plus 5x? You only combine the ones that have the same variable. Okay? Shh. So I'm going to put the same variables next to each other because that's what I like to do. I'm going to put 3x plus 5x plus 2y. Doesn't change the problem at all. Okay? So now I'm combining the ones that are the same. Oh, look. These ones are the same, but sorry, 2y is not the same. Okay? So then I just add the numbers in front of the variable. What's 3 plus 5? 8. 8x plus 2y. That would be my answer.
Really?
Oh, that is.
Because you can't combine 2y with anything else. It's left stuck by itself.
Looks like that is very.
You can only combine the x's with each other. You can combine the y's with each other. But x's and y's, they're not the same. You cannot combine unlike terms, only ones that are the same.
3x.
Thank you to those who are writing, because I don't write just for fun. I write so you get the notes. So you're writing too.
Yes.
Thank you, Lawrence, for having your pencil up and being ready. Thank you, James. Thank you, Leo, Andrea, and Trina. Now, let's go to the distributive part of the lesson. You might have something that looks like this. 4n plus 5.
What is mine?
Okay. Step 1. I like to draw arrows from the outside number to the inside numbers in the parentheses. It's kind of a long step, but it's a short step to actually do. What that means is that over here when I have 4 and plus 5, I like to draw arrows from the number to the outside to the numbers in the inside. So that tells me what I'm going to multiply. So I'm drawing an arrow from the 4 to the end, and I'm drawing an arrow from the 4 to the 5. Step 2, you're going to follow the arrows to multiply. So if I follow my arrows, I get 4 times n plus 4 times 5. Four times n, 4 times 5. And my last step is just to use PEMDAS. So 4 times n is 4n plus 5 times 4 is 20. So there's your answer, 4n plus 20. That makes sense? So I multiply 4 times n and 4 times 5. And I keep the sign that's there. So 4 times n is 4n. 4 times 5 is 4n plus. And you have that written down with your pencil? So you're multiplying the outside number by the numbers that are on the inside of the parentheses. So you might have something like 12 parentheses 2y minus 3. Okay, so I like to draw my arrows because that tells me what to multiply. 12 times 2y and 12 times 3. So I have 12 times 2y, keep the subtraction sign there, 12 times 3. Does everyone see where I got that?
Yeah.
12 times 2y minus 12 times 3. So you're bringing that number on the inside. That's why I use the arrows. It tells you where to go. So 12 times 2y, 12 times 2 is 24. So 24y minus
36.
36. That's your answer. The arrows really help. So right here, my 12 times 2y was my 24y. And my 2 times 3 was my 36. You need colors or you need to highlight which one goes to which, you can. You can highlight that this part of the problem is this. And if you need to, you can highlight that this part of the problem. So you know what to do when you get to your homework. Here we go. One more. One more. Now, there's always a catch. There might not just be 2 numbers in the parentheses. They could put up 10. But we'll just do 3. So 9 parentheses 6 plus x plus 2. Whoa, too many numbers. No, it's not.
No, it's not.
I think we have this.
I think you do.
Hold on, I got a question on this one.
Alright, so I will do my arrows. 9 times 6 to each part of the problem. 9 times x. And I will also do 9 times 2. That's why I tell you that arrows help. So I'm going to have 9 times 6 plus 9 times x plus 9 times 2.
Okay, so
So I have 3 parts of the problem, right? And 9 times 6 is one part. I have 9 times x as another part. And I have 9 times 2 as another. So I know that 9 times 6 is 54. 9 times x is 9x. And 9 times 2 is 18. Now, Once you get here, oh wait, you have to see if there are like terms. There are like terms. You can add 54 and 18. Exactly. So I'm going to rewrite the problem. 54 plus 18 plus 9x. This is why I use color. It doesn't change anything. I just rearrange it a little bit. Because I know that I can add 54 and 18. Okay? Done. Thank you. 54 plus 18 is 72. 9x plus 72 is my answer.
Jesus.
Wait, so what's your score?
9x plus 72. So let me explain. Okay? I distributed all the numbers and we got to this part. 54 plus 9x plus 18. 54 and 18 are like terms. You can add them. We add all day, every day. Okay? So I rewrote it so that they were next to each other. 54 plus 18 is 72. And I'm left with 9x. I can't add anything else because nothing else is a like term. Okay? Trina, you can stop the recording.